and welcome. This is our ACM essay series iteration with Gene about advanced JavaScript. Thankful to have you all here. Glad to get this series kicked off and explain a little bit more about it. But to get us started, what is ACM? ACM is the Association for Computing and Machinery. I am Zachariah. I am the chair. And our mission is to assist in cultivating a thriving and professional community where engineers, scholars, and those looking to learn can connect, collaborate, and elevate San Antonio's tech ecosystem. We're looking to help fund, help be a part of, help contribute, help be a part of in just every aspect we can in the ecosystem of San Antonio. Real quick aside, I am Zachariah Holland. I am the chair of ACM San Antonio, alongside with our speaker today, Gene Tigner, who is my co-chair, and Mark Robinson, our treasurer. Uh, Something else I want to share is we also have a membership. ACM San Antonio does offer membership as well, so you get access to a bunch of different things. We do offer something that we will be creating a sign up for in the future called the associate membership. So those will be people who actively attend events, engage in the community, and all kinds of different things from that aspect. But there is also a full member as well. Full members are ones who pay yearly dues, access to ACM national resources, discounts to workshops like an upcoming one here in June. And we are running for the first full year 50% off for those first members. So right now that is $50, but it is $25 with that cutoff. Um, we also have a bunch of social medias such as our Luma calendar to keep up with events. Our Meetup is another location to keep up with events, and the Dev San Antonio Discord, where you can keep up and interact with the tech community here in San Antonio. And I don't want to delay us any longer, but to give a quick overview, our advanced JavaScript series will be ran by Gene Tigner, my co-chair and an active developer here in the San Antonio scene. This is day one of day 3. We will be running this for 3 days here on this Thursday, same time, next Thursday, 7 to 8. And the Thursday after that, which will be April 10th, where we will be not only doing the virtual, we will also be in person at Project Cowork with some snacks, and you can interact with Gene or ask the team questions or anything else involved there. So super excited to have this, super excited to get started, and super excited to kick it off. Let me invite Gene to the stage. Gene, welcome. Are you excited to get this started?
Yes, I'm very excited.
Awesome. Well, the stage is yours, and have a good one.
All right. There we go. Perfect. Thank you very much. All right. So, as Jack mentioned, today we're going to be going over some advanced JavaScript concepts. And I would like to preface this with the understanding that to me, this is advanced to me. This is what I consider to be advanced in the JavaScript ecosystem. These are concepts that I do not expect someone just coming out of school to fully understand quite yet. Someone coming out of college, I expected to have more of a C-level idea of some of the methods and understandings on some of the code that we're going to be going over today. And anybody else who's coming from other languages, who's not particularly familiar with some of these JavaScript concepts that I will be going over, this is also something I wouldn't expect them, concepts that I wouldn't expect them to know either. But today, what I have set up here, on the left, I have our slides. On the right, I have my console in my browser pulled up so I can do some live examples in case I need to showcase anything or clarify anything or test my assumptions out. And, it's always important to, especially within JavaScript, you don't know if something could be a reference or something could be a copy. Most of the time, reference, but we can easily test that in a few ways, and we'll show some ideas there in a minute. But to get things started, a little bit about me. So I graduated from UTSA in 2020. I'm proud to be a UTSA alumni. I have about 5 years experience in enterprise software engineering here in San Antonio, Texas. And I also have about 5-ish years of JavaScript and TypeScript development experience. To say that I expected to be a JavaScript developer is not something I can say. It kind of was thrown on me several times, and I just accepted my fate. It has paid the bills. So if anybody else is interested in going a web dev route or a Node route or anything using Node, I think it definitely is a realistic path to software development in the modern era. Another thing about me, so just some fun images here. I got some images. This bottom right image here is me and my team sharing a drink in New Braunfels after HEB event. I work for HEB as a software engineer. Was hired last year in I believe in June or July. But I also like to cook, and right here in the bottom left is a nice little burger that I made. But I also really like Cane's. I eat there probably too much, though lately I have stopped doing that for dietary reasons. But anyway, as we say, we're going to go ahead and move on. So today's subject matter, we're going to be talking about array methods. Also, before I move on any further, if you have any questions, put them in the chat. Zach will pop out of the little hole he's hiding in, and he'll ask me questions. I am going to go through this slide deck. If you guys have any super important questions that you need clarification on, I can't see the chat. That's why I got Zach help me out. But at the end, I will have about 10 minutes for any additional questions or anything like that. So don't be afraid to speak up and ask a question. I will stop and I will answer it to the best of my ability. So day one, we're doing array methods. Day two, next week, we're going to be going over objects and object complexities within JavaScript. And in day three, I'm thinking about higher order functions as a topic, but I'm wanting to potentially play with that idea. So I added a to be determined on whether or not I should do an entire day on higher order functions. We'll play it by ear as this goes on. So without further ado, let's start talking about array methods. So, well, arrays. So what is an array? So for the new, so I'm going to kind of speed through this next part. So considering you're a computer scientist or you want to be a computer scientist, you probably already have an understanding of what an array is. An array is just some data shape or data object in our in JavaScript that holds items. Typically, you would want to keep them as like kinds. It's so like a collection of numbers, for instance, or a collection of characters, a collection of words, a collection of Boolean values, or with JavaScript's niceties that it has, objects, or anything you want. This is a completely valid array, except for obviously the spinning cat. But JavaScript allows you to put whatever you want inside of an array, explicitly because JavaScript doesn't really hold you to a type standard. TypeScript will hold you to a typing standard, but that's just a nicety to have for when you want to be more strict with your code base. To give you an example of that, if I make a constant and so let's use this array that I've defined earlier. So let's say array here, I have hello3, and that's, you can see here, I have a word and a number. I can access the record here, and I can change this to a Boolean value, and then my array now has true3. So you can mix and match inside of arrays, and you can make them as big as you want. Most languages, or not most languages, but some languages, they actually restrict you in the space you're allowed to use for the array. You have to predefine the size of your array. JavaScript, you can just kind of make them however big you want. All right, so array methods. So JavaScript has prepackaged array prototypes that extend the methodology using higher order functions for arrays. So a traditional for loop that you probably make in a computer science course in college, you'd have your for, you'd have your iter, your starting position in that loop, i.e. the starting position of your array. You'd have something that conditionally checks where if you're at the end of your array, you would have an iterator to actually iterate over that array, and then you would have something that happens instead of that for loop to capture each individual element of that array and do something with it. So an English approach to this, an English statement for this particular type of loop would be for every element in the corresponding array, print out the array index and array value. And this is nice. This is perfectly fine. You can do this. It's computationally safe. And probably, and no, not even probably, it is faster, very minusculely faster than using the array methods. However, once you start getting into an enterprise field and you start writing code that others are going to be reading, do you really want them to read this every time, or do you want them to read something that's a bit more Englishy and a bit nicer in terms of easy to understand concepts? So let's talk. That's interesting. Can I go back? No. Okay. So let's just go straight into the forEach prototype. So arrays, again, they have prototypes, and so this prototype is going to be the forEach method. And basically what you can do, if you have an array predefined, you can tack on this .forEach, and it acts as an iterator on every single element in your array. So what that looks like syntactically, to get to your individual elements, you can insert a function call. And then, so this is saying for each element in my array, I need to do something. So here, I'm just console logging that element. So if you look over here in my console log, I take the array I just had, and I say for each, and I say each element in this array. This could be anything. I can say cookie, and it still works. And I can say console.log, and then I can log that cookie. And that should, I guess it doesn't run it in this because it's not. But anyway, this is the correct syntax for that. If you ran this, it would print out every console log statement. Anyway, moving on. There are a lot of people don't know, but there is other things you can do with the forEach method. So the forEach method takes in a function call, and in that function call, you pass in parameters. So the first parameter is the element that's actually in the array. The second parameter from the documentation on the MDN is the index. And then there's a third parameter for the actual reference back to the original array. For the life of me, I have not exactly understood why they give us this reference back to the original array. In some programming languages, it's very much a no-no to modify an array as you're iterating over it. I believe C# throws complaints whenever you try to modify an array as you're iterating over it. But I did test earlier, and if you take an array and you do take each element in that array index and then the array itself here, I can say something along these lines of array, that reference to the array, take the index that I'm on for that reference and modify it to whatever I want. So here I'm going to go ahead and say words. And now if I run this and then re-reference my array, it has been modified in place with these words. I've told every single index to be mapped to the word words. So it is a reference back to the original array. And so here on the slide side of things, you can see I have this input array, the indexes, and then the expected output from this. So a forEach loop, that's pretty bare bones. That's probably the most simplistic loop or a method that our prototypes have. They get more complex. I'm not going to go over every single prototype extension that JavaScript has built into the array object, explicit because there are a lot. If you'd like to know more about some of the more interesting ones, go to Firefox's or Mozilla's MDN, which you can find online, and it'll have a lot of information there. But I am going to go over map, sort, toSorted, reduce, and then we're going to have a surprise at the end of this slide deck for some interesting concepts that you can do. So, map. For these next few slides, I've decided to approach it from a problem perspective, because what we do in computer science is we're problem solvers. That is, I guess, the thing that we get paid for the most is to solve technical issues using computer languages. So here, the problem is, given an array of numbers, return a new array that contains the product of the array's current numbers multiplied by 2. And to break this down even more, what I mean by this is every element in the array, say it's an array of numbers, I want to create a new array, which the resulting array has every individual element multiplied by 2 across it. And you'll understand in a minute why I made that very specific distinction when we get to another method. But breaking down this problem, so there are 3 things that we need to do. We need to iterate over every number that is contained in the array, okay? We need to multiply every number by 2, and then we want to produce a resulting array from the input array. So here, this third bullet point, I have my input array and I have my expected output array. So how would this look in a traditional computer sciencey way when you're in school? Well, probably you would write something like this. You would make a for loop. You would set your iteration. So that's what we're doing here. We're iterating over our array. And then we're applying some operation for each element in that array. And in this case, we're multiplying by 2. Well, we also need to store that information. So outside of our for loop, we instantiate a new array. And then inside our for loop, we do some method to add that resulting the original array. We multiply it, and then we add that value into a new array called the result array. So that satisfies this problem set we've created in a traditional way. Array that has multiplied by 2 elements. So, all right. So how do we know that a map would be good for this particular problem? This is the original computer sciencey way of doing things. We can do things more appropriate, or not appropriately. We can do things in a similar way with much less code using .map. But how do we identify that? Well, one good way of identifying that you're probably going to want to use a map is you take a look at your original array and you take a look at what you expect your output array to be. And if they have the same length as each other, then you probably want to use a map. So after processing the input array, the output array will have the same number of elements. For every entry in one array, there is a corresponding result value in the returned array. What does this look like in code? Well, much like the forEach loop, we have the .map. And the .map function will return a new array with the same number of elements as the old array. So we have our original array, which is array, and then we .map, and we're going to say for every item in this array, we're going to do something. What are we going to do? We're going to multiply that item by 2. Well, what else do we need to do? We need to store it, right? Well, we can store it like this: const result equal array.map, and then the operation that we wanted to produce. And that, in my opinion, is so much easier to read than this. Computationally, there is a millisecond difference between doing it the original way with the for loop that you just build and you do the iteration yourself and then you push the results to an array. Though That's becoming, unless you're building something that has an extremely limited amount of space, I would probably go with solution 2 here over solution 1. And we can talk about that more later if we have time.
Hey, dude.
Yeah, what's up?
I got a question of what if you want to perform an asynchronous operation within the map function?
What if you want to perform an asynchronous operation within the map function? That's a good question and a use case that I have not yet come across. So what I'm going to do there is I'm going to say, let's write that question down. And then whoever asked it, let's get back to them if they are in any of our channels that we normally communicate in. I'll look that one up. So, all right, moving on. Array.prototype.reduce. So again, we're going to start off with a problem. And this problem, we're going to say, given an array of numbers, return the sum of the array's current numbers combined. So we're going to break down this problem. Again, we need to iterate over every number that is contained in the array. We need to add each number in the array to one another. And then we need to collect the resulting sum. So we're going to hop through it. So what does that look like traditionally? Well, we set sum set to 0 because we haven't done any operations yet on any of the on the array. Then we have our for loop, and we're iterating again over the array's elements. And then we do a plus equals across each array element to accumulate the summation. Mathematically speaking, you're doing the same thing as this summation notation here. So we have our array above, and you can see how this maps one-to-one quite nicely with this summation. And how this works with reduce is a bit more complicated. So array.prototype.reduce allows us to reduce the array down to a single variable by iterating over each entry in the array and providing some process to it. So according to the documentation provided by the MDN, array.prototype.reduce expects one of two possible parameters. The first one is a callback function. And you've seen that before when we did forEach and we did map. We used a callback function and parameters inside of that callback function, and then some resulting side effect or operation that we were conducting on the right-hand side. Additionally, we may have an initial value to start with. If no initial value is given, then the default initial value for this operation is the array's first indexed entry. So why is that important? Well, array.reduce, you can implement a solution to this specific problem with the specific array in 3 different ways. However, this middle one only works if the array starting index actually is 0. But if we take a look here, we have some A and B, and then we're going to do something across those, across those particular pieces of this array. So in this case, A is going to be 0 and B is going to be 1. And we need to do something, but that's not important right now. What's important is you see that we have this function call, but then we have a comma on the second one in the middle with a 0. So here in the second one in the middle, I'm explicitly telling it to start with the number 0. But on this third one down here, I'm telling it to start with the array's 0th index. Because of the context of what the MDN is telling us, this first one and this third one are effectively the exact same thing. Because of the, where was it? This rule down here. If no initial value is given, defaults the array to the first index entry. All right. So reduce the callback function inside of the map has two important parameters that it wants. The first parameter is an accumulator. So if we look back here, A here is our accumulator, B here is our current value. So an accumulator is the value resulting from the previous call to the callback function. On the first call, its value is initial value. If the latter is specified, otherwise its value is array at the 0th entry. And then the current value, the value of the current element, on the first call, its value is the 0th entry of the array if the initial value is specified. Otherwise, its value is the first entry, or rather the second entry in the array. So what that means is if 0 is provided, or if there is a provided initial value, then it will default to array sub 1. Otherwise, it defaults to array sub 0. So what does that look like if we use a more mapped out approach here of representing the information? Well, for this specific problem, we can do an array.reduce. We have an accumulator, which here is starting at array sub 0, which in our array is currently 0 because we're in this particular example, array is 0, 1, 2, 3, 4, 5. And the current value, which would be the first entry in, or the indexed entry 1 at the array. And then we do an accumulation, so 0 plus 1. So what happens then is the accumulator goes up and, the accumulator is replaced with 1, and then the current value in the array is going to be the next one in the array. So the next time you loop through this, it'll be 1 plus that next entry in the array. And the result is that we can set sum to the result of this reduce. And I'm going to show this in real time here. So let's make an array. Let's make it, I have a lot of arrays here. So let's just go ahead and say array const C, and C is going to be our array. And we're going to say 0, 1, 2, 3, 4. So 0 plus 1 is 1, 1 plus 2 is 3, 3 plus 3 is 6, and 6 plus 4 is 10. So this should result in a sum of 10. So if we do if we do const sum equals C dot reduce, and we pass in an accumulator and our current value, and then it's going to be A plus B. So this should sum everything up. Oops. Oh, I already declared sum earlier. Let me just see about C dot reduce, because this should just return AB, AB, A plus B, 10. All right. You can do whatever you want in here. So you could reduce it down. So you want a product of everything. So you take the product here and say the product would be A times B instead. So because we have 0 in the front, anything times 0 is just 0. So, but let's say you want to reduce, you can reduce anything. So let's say we have const D here, and we're going to have H, E, L, L, O. All right, so, okay, of course it has. Let's see, letters. Let's do that instead. And then we're going to do H, E, L, L, O. All right, and then we do letters. So we have individual characters. Let's do a letters dot reduce, and we'll do AB, and we'll add all of these together, and that should be able to give us a word back, or one string back. So as you can see here, it's already interpreting that it's going to be the word hello, and there we go. So not only can you reduce across numbers, but you can also reduce across letters. You can reduce across anything that's inside of your array. Now, doing that with an array with mixed types is going to be weird. Say if you have, let's replace in const letters, or in the letters array, let's replace the first element with a 5. So that's a number, right? But how does that look whenever we do a reduce? So if we do a reduce here, you can see it converts it into a string still. So it does have some unexpected behaviors. You wouldn't think that this would work, but JavaScript's like, oh, you probably meant it to be a letter. Let's go ahead and put it in the word. All right. So getting away from reduce. Again, which one would you rather see in code? Would you rather write this on the bottom every time or read this every time? Or would you rather read the top one? We have what, 1, 2, 3, 4, 5 lines here. Obviously the brackets don't count, so maybe 3 lines. Or you could do 1 line or at worst 3 lines, depending on how you're line breaking. And I personally prefer the top over the bottom. All right, Zach, how are we doing on questions? I'm gonna take the silences, we're good. All right, so sort. Given an array of numbers that are out of sequential order, sort the arrays so that they are in order from least to greatest. In breaking down this problem, again, we're going to iterate over every number that's contained in the array, and then we're going to use some sort of compare or to sort the array, and we're going to use a sorting algorithm to do this, and then we're going to have a result that's returned. So this is where things get a bit more complicated. This is a JavaScript approach that you would potentially probably put together on an exam that you're doing in a computer science lecture. So here we have 2 for loops that are iterating through every element in the array. They're doing some comparison operation between 2 elements in that array, and then we're swapping the elements based off of that result. In this case, we are iterating through everything and sorting them in ascending order from 1 to 8 in this case. This is fine. Again, this is fine. But would you rather write this, or would you rather write something a bit more simple? So let's take a closer look at the .sort function. So here I would also like to show you guys before we get into this. I could create a constant and store the array, or I could just have the array itself. So 1, 2, 3, 4, and then I could say for each right off of that array, and then do some operation, or I could do a .map on that immediately. I don't have to store the array anywhere. I could just do the operation right off of the actual object itself. That's some of the nice flexibility that I do like about JavaScript. Is it's very quick to check some of these prototypal arrays or prototypes to make sure that they do what you think they're supposed to do. So here we have an array that has numbers that are out of sequence, right? And then we have this .sort. But what are we going to put inside here? Well, let's take a closer look at the documentation here. So we have to have some sort of compare function. And that compare function, we are going to create, it needs an A and a B. So an A is the first element that we're going to be comparing. That will never be undefined. And B is going to be the second element for the comparison. That will never be undefined. And it should return a number where a negative value indicates that A comes before B. A positive value indicates that A should come after B. Or 0, or not a number, indicates that A and B are considered equal. And down here, it has this very helpful to memorize this. Remember that A, comma B, such that A minus B. And that sorts numbers in ascending order. And we'll get to why that does that in a minute. We'll take a closer look. So let's go ahead and fill that in with that particular call. This is very useful. This particular A, comma B, A minus B, really great as an introduction to just things with numbers. But you can also use sort to sort alphabetically. And we'll get to that in a moment as well. All right, so let's take a look here. So we have this array 3, 5, 2, 1, 8, and we have the .sort, and we want to sort them in ascending order. So we have A, comma B, and then such that A minus B. So why does this result in an ascending order value? Well, if we go back to this definition and we look at a negative value indicates that A should come before B. So if we look at these first two values in this array, 3 minus 5 results in a negative number. So that tells the sorting algorithm, hey, this is in the correct order. 3 should come before 5. But obviously we have the rest of the array to work with. Then it would check the next sequence in the array, then the next sequence in the array until it comes out with a sorted array. So let's take a look at that. Let's go ahead and write this in real time. Let's do 3, 2, 9, 10, 3,999. Just put an extreme in there because extremes are always nice. And we're going to sort them. And we're going to sort them A, B, and we're going to do A minus B. All right. So that sorts my array. Now I have an array that came back in 2, 3, 9, 10, and this. Now, another thing to understand is the dot sort will sort your array in place. That means if you have a constant array, like some array, say I have, let's do n. And then let's say we do 3, 2, 9, 10, 3, 9, 9, 9. And then, okay, I can't do n. Const example. Let's do the word example. 3, 2, 9, 10, 3, 9, 9. And then, so this is kind of a bad example because only the first two elements in this array are messed up. So let's go ahead and change. Let's say example 9. So that's going to be 2. Let's change that to a negative number. Let's say that's going to be a negative 2,000. And then we'll do example just to make sure that's right. Okay, so we have this array here. And if I take example and I do a sort on it, like I did before with the other array, A, B, and I do A minus B, and I hit enter, the array example has been permanently modified with the new set. Now, that might not be the expected behavior you wanted. That's where .toSorted comes in. ToSorted will not sort the original array in place. So let's say example 2. So const example 2. And let's go ahead and give it some more numbers, just some random numbers here. And I say example2.toSorted instead of sort. And we're going to do A, B again, and we're going to sort in ascending order. So that does that. But if I now come back to example 2, it's still in its original order. What's happening here is ToSorted creates an entire new copy that is isolated away from your original array, where a sort will literally manipulate your original array. Several use cases for that, but that's not what this course is about. So let's continue on. All right. So I'm just talking about that same problem here that I just showcased. Here's probably something that not a lot of people are familiar with. This copy input array example, where I'm taking this array and I'm doing the spread operator. This is just a quick and easy way to create an isolated copy of an existing array. That's in JavaScript. What this does is it spreads out this array and it puts it into this new instantiated version of this array. So you have two standalone copies. This spread operator, extremely valuable when you're doing a lot of array manipulation. All right, moving on. So let's talk about sorting some words versus numbers. Make sense. The documentation makes it very clear of how I would want to use that to manipulate a numbered array. But what if we want to sort something alphabetically? How can we do some sort of operation across those? Well, remember, the only thing you need to give the sorting algorithm is a function that produces a negative number, a positive number, or a 0 for equality. So that's exactly what the local compare function will do when you give it two strings. It'll compare one against the other, and it'll tell you sequentially, alphabetically, which one comes before which one. And it would do that by producing a negative one, a 0, or a positive one. So if I have this array of words that are out of sequential order, again, I really am bad at making example arrays because, again, the only two values in this array that are kind of out of order are apple and elderberry, though technically elderberry should be at the last. So it will wind up getting compared to everything in this list. But anyway, so let's take a closer look. So we're saying that I have this up here. I have up at the top, I've set, hey, I am going to create some function that takes in an array, and then I'm going to return a copy of that array that is sorted across a local compare of words. So I'm going to get them in alphabetical order. So what's going to be in A is the first entry in the array, and B is going to be the second entry in the array as the first thing that's iterated over. So we compare elderberry dot local compare apple, and that will produce a number for us. But let's take a look at how that works. So if I type in elderberry and I do a dot local compare across apple, I will get a uncaught. Local compare is not a function. Oh, locale with an E. I always forget that. So it returns a 1. So this 1 means that apple should be coming before elderberry. If I did this the other way, I should expect to get a negative 1. All right, so it's telling me that apple, in this case, since it is a negative 1, apple does indeed come before elderberry. Now, to give you an example of equality, let's do apple.locale compare, and let's compare it across apple. And we get a 0 because they're the exact same thing in terms of being a string compared to another string. So what this tells us is it satisfies the constraints that we need to get things sequenced with the two sorted array or the sorted array. Let's go down here. So this will produce a 1, which will then sort our array. So let's go ahead and take this. So let's say I'm going to go ahead and make an array. I'm going to make this array elderberry. I'm going to make it apple, and I'm going to throw a wild one in there. I'm going to say I'm going to put banana and cherry out of order. Banana, and let's go cherry. Right, and then we're going to sort them. So we're going to sort this array, and I'm going to choose to sort in place here, and I'm going to say the two AB for the function, and then I'm going to say we're going to say a dot locale compare, and then B. So it's going to go through every single element in the array, and it's going to decide in place where. Excuse me. I have an idea that I just thought of that I want to show you guys here in a second. So this should sort everything in place, and if I've written the syntax correctly, you should now get an array that's in order. So you have apple, banana, cherry, elderberry, alphabetical order. But you probably want to know more about what's actually happening. So if I come in here, I believe I should be able to get an index and a reference to the array. And I do want to return this here, but I also want to see if it'll let me. It might not let me do this in the console, but we're going to try. Nah, it didn't let me do it. Okay.
Hey, Gene, coming out of my hole again.
What's up?
We did have a question about the complexities of sorting. How would you sort objects versus strings or numbers?
I was going to save that until we went to our objects
Yeah, you can save it.
topic for next time. However, in order to sort object against objects, usually objects will have some unique piece to them, or you would want them to have some unique piece to them. So a typical object might have an ID or an identifier, a unique identifier. You could sort those objects in that array across that same unique identifier by comparing the unique identifier to other unique identifiers. Or you could also produce your own complicated method or logic that will produce a negative, a 0, or a positive number, and then sort based off that. But we can talk more about those complexities whenever we get to the objects discussion next week. All right. So we have about 15 minutes left. I don't want to rush, but I do want to show you guys how you can create your own prototypes. But I really want to emphasize that you should not do this in production code. Why? Because the array.prototype is something that when Node, the people who are behind Node, the people who are behind JavaScript standards, decide that there should be a specific piece or a specific function in the overall library, that's the prototype is what they control. So if you make your own and then JavaScript or Node later on decides, hey, we want a function called this that you just so happen to make a prototype of on your end, then your stuff's going to break and your production code's going to break the next time you update your JavaScript library, because it'll cause a clash. But without further ado, at your own risk, I suggest playing around with this, but never do this in production code unless you have a really good reason to modify the array prototype. You can even overwrite the forEach loop and the map loop and replace them with your own, but really don't do it. So we're going to have this problem here. Given an array of numbers that has duplicates, produce an array from that array. Produce an array from that array that only includes the unique instances of those numbers. So basically, if I have an array of, say, 1, 1, 1, 2, 2, 2, 2, 2, 3, 3, 3, the resulting array should only say 1, 2, 3. So there are multiple ways you could do this, obviously, in JavaScript, but we're going to go over 2 ways of doing it here. So the syntax for creating your own is you define an array.prototype and then whatever word you want. Here I chose the word unique to say that, hey, the resulting function should, or the resulting array that comes back should be only an array with unique elements. And by the way, this function that I'm about to write, I believe the way I've written it only works with numbers. So keep that in mind. Then we're going to say it's equal to some function. And inside of that function, we're going to use this. So this here is a keyword that points us back to the array that we're processing. We're going to filter it. So we didn't go over the .filter function, but what the .filter function allows you to do, let's say, let's go back up here, and I want to filter this out. And I want to filter it across some word, but I only want to filter it down to words that have less than 6 or less letters. So I say word dot it's greater than, no, is less than or equal to 6. I believe that should work. Yep. So here you'll see that it stripped out elderberry because elderberry didn't match what I was looking for in my filter. So we're going to filter this here, and we're going to filter using the item and the index. So most of these functions, they'll expect the element of the array, the index value at that position in the array, and then also there's this optional parameter for the array itself. So what are we going to do across these items using the item in the index. Well, again, we're going to use the this operation to reference this array. And then we're going to say we want the index of this specific item, but we only want it if it is equivalent to the index that we're at. And I wish I had a slide that explained exactly what was going on here. But basically, index of is a prototype that exists on array that will only return the index of an item the first time it sees it. So it's going to go down the array and check for the index of, or it's going to look at the index of the item. It's going to go look at through items. It's going to try to find that item that you've referenced, and then it's going to look at that entry in the array, and it's going to give us back the index value. But it will only ever give us back the index value of the one that it found, and it's always going to be the first one in the array. So if I say something like 4, 4, 4, 4, 4, and I say dot index of 4, it's going to give me back a 0 because it found a 4. It's like, okay, all you wanted was to find a 4. Here's a 4. It's at this position. It doesn't care about the rest of these. So what does that look like whenever I construct this array? So let's do that. Let's do this. Let's say we have 1, 1, 1, 1, 1, and then let's say we have 2, 2, 2, and let's do 3, 4, 3, 4. Well, if this function, we can test this out. We can do a dot filter. We're going to say for an item and the index that we want. We will say that we want to conduct this operation on it. So we'll do, this is the filter. All right, so filter that. And then the result is we're going to do this. Yeah, let's do this the keyword because this should work here. Index of, and then we're going to say item. As long as that index is equivalent to the index that we pulled in, then that should satisfy our, okay. This dot index of is not a function. Okay, yeah, doy. Excuse me. Let me think here. Instead of using this, since I can't seem to use this in this context, let's come up here. Let's modify this to where we get the reference of the array. And then we're going to pass in that reference of the array here. And that should, there we go. All right, so what I've done here is I've basically made this exact same thing. I'm not using this in this context because I can't use it outside of this. Why? I don't know. I'll have to get back to us on that one. But as you can see, I have this hodgepodge array filled with multiples of the same item. I do the filter. I grab the item, the index, and the array, and then I say for each time I for the filter, for the logic of the filter, I say, hey, grab that array, look for the index of that item that I've pulled out, and if it matches the current index that I'm on, then that's going to be a value in the resulting array. So let's see. Let's go ahead and make that dot prototype dot unique. And we're going to set that to be a function. And we are going to return, this dot filter. And we're going to say item index. And we're going to say this dot index of item. And we erase this index. And pop. Okay, so now I have created a new array.prototype. So if I take this array to the same array I did before, 2, 2, 3, 4, 3, 4, and then I pass it the dot unique that I just made. Oops, my bad. I get the exact same result. So I did say that there's multiple ways to do this. You could make this filter for each individual item in the array and do a comparison across the index of that you found. Or An error occurred. Hooray! Fantastic. Can I reload this? All right. Or you could just do array.prototype.unique is equal to, so let me click this real quick. Array.prototype.unique is equal to function here, and I can return. And earlier I talked about the spread operator. Well, I could say a new set this. So set here is a class that when given an array of non-unique items, it'll return an array of unique items. So I could say const example is equal to, so example 3 is equal to 2, 2, 2, 2, 2. So that obviously very simple twos array, and we are going to say const set a set is going to be equal to new, and then I set is the class, and I'm going to pass in example 3, and that will give me a set. And in that set, it returns an object that has entries in it, and that spread operator will take, if I say I want to turn this into array, I can use the spread operator. So I say const a set array, and I do that the array wrap, and I said I'm going to spread across a set here. So now that turns my object into an array. So here I went from this object that has entries in it that are enumerated to an array. And so as you can see, with all of this combined, I can very clearly state dot prototype. Prototype. We're going to do unique to, and we're going to set this equal to function. And we're going to return spread operator. We're going to use a new version of set, and we're going to do it across this being the array we're processing. And oops, I forgot this. There we go. And now if I give it example 3 again, we're going to say example 3 dot unique. We're going to run it across unique first. So unique, I guess I lost the original unique because I had to reload the page. So let's do unique 2, and across that, and we get an array of just 2. It reduced it down to just one element in the array because it had just 2s in it. If I gave it another one, say I give it like 2, 2, 4, 4, and then you do unique 2, gives me 2 and 4. All right, and that's pretty much it for today. I do have, if you'd like to challenge yourself, I don't know why this keeps breaking. It's because I'm doing a lot of stuff in the console and I'm overwriting values that it might be using. But if you do if you are interested, I have a repository that I have not yet made public, that I am working on making public. It's going to have examples of some of these array prototypes, and it will be executable. So I'll have a list of commands that you can just run ad hoc, however you want to run them. It has some predefined arrays, and it puts in examples of traditional, like computer science student methodologies of creating for loops and stuff like that to iterate over things, and then the equivalent counterpart for what you would see or use for the existing array prototypes. Additionally, I would also love to show you guys the MDN. So here is the array MDN documentation, and you have some static methods here, but you also have these instance methods, and this is honestly what we've been going over. There's a bunch of these, and they're all very well documented for MDN. So, flatMap. a map versus a flat map. What's the difference there? You can come in here, look at that. You got dot push, dot pop. Those are pretty standard. To add stuff to an array, you use dot push, which you saw me use at the beginning when I was using that for loop. And then you have the dot pop method that will remove elements from an array. Reduce, we talked about. Reduce right reduces from the opposite side of the array instead of from the front. Reduce from the back. Reverse an array, just turn the array around. Shift, slice, sum, sort, splice. A bunch of different things in here to play around with. So, all right, Zach.
Awesome.
What we got?
Well, thank you, Gene. Excited for that. Excited for potentially the little test you kind of gave them. When can they probably expect that? Whatchamacallit?
A
Your repo to
repository?
come up. Yeah, got to work
So I'm
for
going
it.
to go ahead and, I apologize for not having the repository ready today, but I will post the repository in the DevSA Discord this
Cool.
weekend. While I'm getting the objects discussion ready.
Awesome.
So,
Okay. Well, excited to have had you, Gene. Looking forward to next week. Same time, same place, same YouTube channel. Hopefully, same format, and you liked it here. Appreciate for having you on, Gene, and look forward to seeing you next Thursday.
all right. Thank you guys for having me. I appreciate y'all's time.
Cool. Some final notes before I jump on out of here. I appreciate you all for hanging out with us at our first ACMSA series of the year. Excited to have Gene back again. But that was our first iteration. Expect the same time, 7 p.m. next Thursday. Go ahead and put notify on your list there. Subscribe to the system, subscribe to our calendar. Come check us out. But I'd also like to take a note here for some cool upcoming events. We have our Coder Study Group happening March 29th, this coming Saturday. Our next event, next April 3rd. So that'll be day 2 of Advanced JavaScript. We also have a new PyTexas meeting happening that is virtual. So you can also attend that while sitting in your chair like I am right now on April 1st. That is happening a little bit later from 8 p.m. to 9:30. Our final day of Advanced JavaScript will be April 10th. That will also be in person, as well as Byte Night, a new event that's coming through from the community. Excited to see what's happening. I believe that's their first event. So go check it out on April 3rd. Be a fun evening with them. Check them out. I'll share the description in the chat with you too. Um, Also, a big shout out to our continuous sponsor throughout these past couple years is TechBlock, constantly helping move the bar forward, helping supply us space, helping out the community, helping out all the tech you see and all the events happening with the tech ecosystem. Excited to have them on board as well. Additionally, I'd also like to take this as an opportunity for you to hopefully submit us feedback, whether or not you do it now or do it after all of our JavaScript ACMSA series events. That form's always open. Select the event. Let us know what you felt. Let us know how we could improve. Let me know how I could stop talking as much. Appreciate that as always. But without any further ado, not trying to stay on here too much longer. Thank you all so much for attending our first ACMSA series of the year. These are some reminders. Look forward to seeing the community and have a good weekend.